So this is the answer key for our vectors assignment. Hopefully these notes will work well for you and enable you to work through your solutions, verify anywhere where you may have had any problems. Please do let me know if you have any further questions. I'll try to tag a couple of spots in these so that you're able to jump ahead. So starting with question 1, it asks us to resolve each vector into its x and its y components. So I want you to think of each vector as if they were triangles. The vector length, so that's always going to be your hypotenuse, is 14 here. We have an opposite side, which is the same as our y value. Remember, we have y to the sky. If you're thinking of your vector components, y is vertical, x is horizontal. And then our adjacent side is equal to x. So if I'm going to figure these out, it doesn't matter which one you choose to solve first. If I go for the x vector, I haven't used this tablet in a while and my writing definitely hasn't improved with it. So if you want to find the x vector, x is the adjacent side, and we know from SOHCAHTOA that CAH, cosine, uses adjacent and hypotenuse. So the cosine of 52 degrees is going to be equal to our adjacent, which is our x, divided by the hypotenuse, which is 14. Rearranging that is going to give us 14 times the cosine of 52 degrees equals x. And x is equal to, putting it into your calculator, you should have got 8.6. Okay, so that's our x component. Now we just need to figure out the y. Now, if you want to simplify things, whether you use sine or cosine for x, you're going to use the opposite for y. It just depends on how your triangle is drawn, so just watch for that. If you've referenced your angle from 0 degrees, 0 degrees is here in our positive x-axis. So this one is referenced from 0. Your x vector will always be cosine, and your y vector will always be sine. So the sine of 52 degrees is equal to our y vector divided by 14. You notice the same format. So in terms of rearranging, there's not any new rearranging. If you rearrange the last one, you can just memorize the format. The length of the vector times the sine of the angle from 0 degrees is going to equal y. And putting that in your calculator, you would have found that y is equal to 11.0. Now, the nice thing about putting your angle in reference from 0 is you're not going to have to use logic to do a double check to see should those be positive or negative. Now, when I look over here, this vector 14 points in the upward direction, so that means it's going to have a positive y, but it's also pointing towards the, I'm going to think left and right for a second. It's also pointing towards the right, so it's in the positive x direction. So we expect a positive x and a positive y, which is exactly what you've got. Simple enough question, very, very critical step. Now let's jump over to B. We have another vector with 37 degrees. We've got an angle of 74 degrees. Now note, this angle is not referenced from 0. So you might want to pop your little crosshair in here to figure out, okay, there's 0 degrees. What is the angle from 0? It's going to take a little bit of thinking on this one, perhaps. If you don't put the crosshair in there and you just use 74 degrees, it is possible to get the right answer. You're just going to have to think about where is x and where is y. So if I'm just to help anybody using that method, sorry, my lines aren't very straight. Y is the vertical, y to the sky. X is horizontal, x is across. So if you're using the 74 degrees, you're going to have to actually do a stop and think, is my cosine x or my sine x? I'll give you that answer in a minute, but first we'll do reference from 0, what we get from our x vector. So from 0 degrees, that vector, the new angle, is equal to 270 degrees minus 74. So it takes us, I don't know if I can change my ink color in here. If we go all the way around to 270, that takes me to the y-axis, and then I have to go back 74 degrees to get to the vector angle. So that's why we subtract the 74 degrees, and that leaves us with 196 degrees from 0. So if we're using that, our x vector will use cosine, just the same as in the first one. So we're going to have 37 degrees. We can use exactly the same rearranging as the first time. Cosine of 196. And then that will give us a vector length of negative 35.5. It's negative because x is pointing towards the left. So our x is in the negative direction. Our y is pointing downward, so we are also going to expect a negative y. So our y vector is 37 degrees. Oops, not degrees, just 37. No other degrees that we have in there. I don't know. Might be able to delete. There we can. Y vector is 37 sine 196 degrees. And that gives us negative 10.2. So those are our two pieces that we needed to have for this particular problem. Okay, so that's one way to solve that. Now, I'm not sure if I have enough space here. I'm going to try to set it up. What I'll do is I'll post a second solution for this one. And I'll post the second solution if you use the 74 degrees. In this case, if you use 74 degrees instead of the angle from 0, y is going to be your adjacent. So in that case, these are going to flip, which one's sine and which one's cosine. So I'll try to post a second solution with just that problem so that you are able to solve that one just for the sake of not having a whole lot of space here. Let's jump ahead to question 2. Question 2 is probably the easiest question on there. It's scaffolded into 3 parts. I would ask you for 3 parts on an exam as well, just to help you break the pieces down rather than just asking for one piece. So first, determine the total x and y forces experienced. So newtons are just a force, it's not north-south. So make your little XY chart. XY charts just help to keep things organized. We have x values on one side, we're going to put y values on the other. So these are my y's, and this is my x. Now note, they don't have positives and negatives on them, so you need to add those in. So this one's a negative x, and that one's a negative y. Putting the values into our chart, we'll just categorize them. So we have a positive x of 4,595. We have a negative x of 654. Then on the y's, we have a positive y of 2,546, a negative y of 1,495, and then we're going to get the sums, or the total. So we're just subtracting them because we want to subtract the negatives from the positive. When you subtract them, your x value should give you 3,941 newtons, and your y value should give you 1,051 newtons. So now that has question A done. So there's your totals. B is a sketch to show the sum of the resultant x and y vectors using tip to tail. So we're going to draw our new sketch. This is going to let us calculate C. So my x is in the positive direction. So we'll draw a little sketch in the positive. There's our 3,900 and, oops. Let's see if I can delete this. I'll start over. So in the there we go. A little tricky to edit in this program. So in the positive x direction, we have 3,941 newtons. in the positive y direction. So straight up from that, we have 1,051 newtons. And what we are, oops, let's change that. It's 1,051. And we are going to be looking for our resultant. Notice I've drawn them in the tip to tail configuration so that we can see our angle. This is a nice one. We don't have to correct because our angle is going to be from 0 already. You guys can probably see all the funky stuff going on in the background when this is trying to edit. All right, so we've got our B is complete. We've got tip to tail addition drawn. Now we're on to C. C is calculate the resultant, or the sum of the forces, and the direction. So we've got our angle marked, and here's our resultant. So you guys know the resultant uses Pythagorean theorem. So resultant squared is going to be equal to 1,051 squared plus 3,941 squared. Which gives us a very large number. That is normal. Sometimes that's when it's great to know that answer button in your calculator. So we have 1,663,6,082. I got to think about how to read that. I think that's 16,636,082 newtons squared would be our resultant, but we're going to take the square root of that to give us a number that's reasonable. So we should get a number somewhere in the couple thousand range kind of thing. Should be in the thousands as opposed to the millions. So that's your clue that you just need to do a square root. It's not that you've done something wrong. So we get 4,079 newtons. So that's our resultant. So that's the length of the vector. Now we need to know what the direction is. So our direction uses tan. Now I often write this in the rearranged form. So we're looking for the angle. So we do inverse tan, and then we just put our tan ratio after that. So tan is equal to opposite over adjacent. So we're going to put our opposite first. So if I look, opposite is my y, adjacent is my x. So opposite first, 1,051 divided by my adjacent of 3,941 gives me an angle equal to 14.9 degrees. You can round that to 15 degrees. Whole degree is all you really need to have here. So the total, so that's everything we need to calculate for C. So the total, if I was going to write my final answer, is 4,079 newtons at, see if I can, at 15 degrees. So that's your answer for C. Pretty straightforward, lots of little pieces. That's why these are multi-step questions. Pythagorean theorem and the tan ratio are the two biggest things. Pretty simple question. One final step, last question. Question 3. I know I've put this on a separate page just to make sure I have room for everything. We have two vectors that are not at right angles. We want to figure out what is the sum of them. So we're putting the two together. Given the following two displacement vectors, that just means two distances. We're going to go 18 meters at 122 degrees, and we're going to go another 10.3 meters at 47 degrees. I want a rough sketch of the vector addition. And when I rough sketch, I'm going to do a really rough sketch here with my tablet, and then I want you to find the x and y components and then find the sum. So basically we're going to do question 1 and question 2 combined together. So if you nailed 1 and you nailed 2, you probably nailed this one as well. All right. In terms of our sketch, I always like to start with my little crosshair. There's my 0 degrees. 122 degrees is going to send me off somewheres in, somewheres in this direction. Let's undo that. See if I can draw a straight line. Okay, there it gives me, bear with me, this is a pretty rough drawing. So that's my 122 degrees. If I get too close to where I've drawn before, it causes some trouble for me. So that's our 122 degrees at 18.0 meters. And then we have, once we get here, we have our another crosshair, and we're going to go 47 degrees. So somewhere's off here. We're not going to go quite as far. This is 10.3 meters. And that's 47 degrees there. And our resultant is going to be, oh dear. The resultant is somewhere's there. So we're getting close to 90 degrees again. If we use our sketch, if we've gotten anywhere close to scale, I'm not sure we have, but it gives us a rough idea. So that's roughly what our vector addition sketch is. So that's our A. At least that tells us kind of what area we should be in when we get our X's and Y's. All of our Y's should be in the positive direction because everything was pointing upwards. Our X's, we're going to have a negative one and we're going to have a positive one, and they're going to partially cancel each other out. Are we going to be on the positive side of X or the negative side of X? Well, we're going to have to use our math to figure that out. So now we're going to find the X and Y components. So I make my XY chart. All of these vectors are referenced from 0 degrees. So when we go from 0, X is cos, Y is going to use sine. We don't have to do any recalculation. The general formula we'll have is the length of the vector, or the size of the vector, the magnitude, times, could be cos if we're going to find X, cosine of the angle will equal X. If we take the length of the vector times sine of our angle, we're going to get Y. You can memorize those if you want, but if you just look at what happens if the vector is between 0 and 90, you will get X is cos, Y is sine without having to memorize, just being able to draw a little picture. So let's put those values in. I get 18 cosine of 122. Nice thing about putting this in is it's automatically going to tell me if it's positive or negative. I'm looking for the X value. It should be negative because I'm going in the leftward direction. And if you put that in your calculator, you do get a negative 9.5. And it would be meters because it's a distance. If I look for the Y, Y should be positive because it's pointing upward. And we're going to have a positive 18 cosine of 122 will give you positive 15.3. Okay, so there's vector 1. My chart's not looking very pretty here. I think this program will not be used again for this purpose, but it was worth a shot. Now for vector 2, we have 10.3. Same thing, cosine of, in this case, 47 degrees. Now, 47 is in the positive X, positive Y quadrant, so we should get a positive X and a positive Y. Cosine of 47, if you put that in your calculator, times 10.3 is going to give you a positive 7.0. If I do the same thing with for Y, I'm going to have 10.3 sine of 47. And we get a positive 7.5. Now we find our totals. So now we've done B. We've got the X and Y components for each. Now C wants the resultant or the sum. So we find the sum and then we have to put them together using Pythagorean theorem. You never have the sum vector unless you've used Pythagorean theorem. So to find the sum vector, add these together. Negative 9.5 plus 7 gives me a negative 2.5. Positive 15.3 plus 7.5 gives me a positive 22.8. Now we have to do Pythagorean theorem. I'll draw X first. X, we're going in the negative direction, 2.5. Now we're going to go in the positive direction, 22.8. Our resultant going to be there. The angle we know from 0 should be bigger than 90. So we're going to actually have to do a little bit of calculation with this one. We can tell that we're going to have to, it's not in the first quadrant, so we're going to have to do an angle correction. First, we'll find the length of the vector. So our resultant length is going to be equal to, first we'll do the resultant squared, we follow Pythagorean theorem, 22.8 squared plus 2.5 squared, which gives us a total of 526.09. We take our square root because we want just r. Pythagorean theorem always makes us do a square root somewhere. And the resultant vector, which we're looking for, is equal to 22.9 meters. Now we need the angle. Now to find our angle, we're going to find the angle in here. Then we're going to have to decide, are we going to add or subtract it to something? Because we know we have to adjust it. In this case, we're going to have to go backwards from 180 degrees with this angle. So it's actually going to give us a negative angle if we put the right signs in. If you don't put the right signs in, like the negative and positive, you get a positive angle. You just have to use logic to decide what to do. So our angle is going to use tan. Tan, I always write it out, tan is opposite over adjacent. So opposite goes first, so that's going to be our 22.8. Adjacent is going to be negative 2.5. Should maybe put the negative sign in there as well. So if you put that in your calculator, you would get an angle of negative 84 degrees. Well, it's negative because that angle is back from 180, so corrected. You get 180 degrees minus 84, which gives us an angle of 96 degrees. So the sum, this is the final piece of the question, is equal to 22.9 meters at 96 degrees. Now, showing all of those steps, there's all kinds of part marks in there, partial credit. I've got the A, B, and C to hopefully get you through each of the parts. That covers all of it with direction. If you were to give me your angle without it being corrected, you're going to get part marks. So show me work for everything. And I promise I will grade fairly. I think you should be able to follow through pretty consistently. Let me know if you have any trouble or any questions with them.